Hello everyone, this is Udaditya from TechSpark bringing you another session covering data engineering question and answers. And in today's topic, we're going to discuss about a very popular ingestion tool which is known as Apache Kafka. In real-time projects, most of the streaming pipeline uses Apache Kafka as an ingestion tool, and we're going to understand the core concepts and the architecture behind it. So as usual, before starting off, I would like to give a brief introduction about myself. I have been working in data engineering domain for almost 9 years with various projects and involved in creating data pipelines for several clients. I have also built pipelines on on-premise as well as cloud servers using batch and real-time ingestion. I also train candidates in this field to help them build an integrity profile with our comprehensive course covering all the necessary topics of data engineering. So now let us understand a bit about Apache Kafka and what are the core concepts behind it. So Apache Kafka is an open source platform that processes and stores streaming data in real time. Now you must be wondering what is streaming data and why am I emphasizing on this word, particular this word streaming. So usually when we do any ELT on data, or any ELT stuff on data, we're usually dealing with the batch data. Batch data means that in any project or any industry whatsoever, the data is getting accumulated from different sources or from different applications, and then the data gets stored into, say, an RDBMS or any file storage. That could be cloud or it could be a Hadoop data lake. So once we store that data, at the end of the day, we process that. We ingest the data into our, be it PySpark or be it any AWS ETL tool, or we could simply ingest the same into our Hadoop cluster, and then we do the processing. So we are just working with a bunch of data that is already stored somewhere. Okay, we are not kind of working on a continuous data. Continuous data, as in the data will be flowing in 24/7. Okay, it's not like the data is kept somewhere and from where we are ready, the data will keep on coming in, and also at the same time, we will have the processing engine running. So as and when the data is streaming in, we are processing the data and also storing the result into some DBC. It could be a Hive database or a NoSQL database, which are more suited for some transactional cases. So the core concepts, if I talk about in Apache Kafka, is first the event streaming. Kafka is built to collect, store, and process streams of records in real time. Now, this real time means it's a continuous data. The data will be flowing in 24/7. There is no abruption whatsoever. Events are messages that contain a key value and timestamp. Now, timestamp over here is one of the most important factors of the data. Why? Because whenever the data is generated, there will be an event timestamp. Event timestamp means that this is the time the data was generated. Suppose now my time is 8 p.m. IST. Okay, I'm sitting in India, and the time is 8 p.m. Now I'm getting data from, say, any other country into that time zone. Okay, so the event time will be where the data is generated into that time zone, and I will be collecting that data into my Kafka topic. So that's the significance of the timestamp field as a whole, because it will indicate when the data is getting generated, not the data is getting ingested. Obviously, I'm sitting at India at any city, okay, and I'm ingesting from here into my Kafka topic, even if my time is 8 p.m., but the event timestamp could be something else based upon where the data is generated, in which country, in which time zone, right? So based on that, we can understand that from where the data is coming or what is the timeline of the data. Since we are working on a continuous data, so we have to be very specific about the timestamp. The other two, the other two fields that we must be aware of are the key and the value. Now, out of the two, value is the actual data. Actual data means whatever the attributes or whatever the columns that are being thrown to the Kafka. Okay, so those will be contained as the value, and obviously it will be in binary format because of the serialization thing as discussed in the previous one of the Spark sessions. But the fact of the matter is, the value will be the data, and the key will be part of the data which will be useful for distributing the data across Kafka cluster. So what is Kafka cluster, how the distribution happens, all these, and also you might have noticed that I have been talking about Kafka topics to send the data into Kafka topics. So each and everything I will cover in this session, and you will gradually get to know what are all the these components that I'm talking about. Okay, so the second point is publish subscribe model. Producers publish data to Kafka topics, consumers subscribe to topics and process the data. So now, since it's gonna be an event streaming, okay, it's gonna be a streaming data continuously coming in 24/7. So there would be some agency or there would be some factor that is producing the data or that is kind of like flowing out from where the data is flowing out, right? So that one is known as the producer, where the data is getting generated. Okay, and the data is getting generated 24/7, right, continuously without any abruption. So that is known as the producer, and where the data will be consumed. Suppose a data is generated in some other country or in some other application. So that application is the Kafka producer. Okay. Now me being over here to ingest the data or to consume the data, whatever it is. So I am the consumer over here. So the two components from where this in and out happens is one is the producer who sends the data, and the other one is the consumer who receives the data. Right. The third point is the distributed system. Kafka is designed to scale horizontally. It distributes data across multiple servers, which are also known as brokers, providing fault tolerance and high availability. So, since Kafka is part of the big data ecosystem, even though Kafka is not necessarily should be run in data lake, it can run in your local machine, it can run into any cloud services, or it can run in the Docker containers. But Kafka works in a way, the Kafka works in a way, it is similar to Hadoop data lake, or it is similar to say Spark in a distributed engine. The way it works is that it has a cluster setup, meaning it will not be worked upon only one node or only one container. Okay, so this container means is just a commodity hardware which consists of RAM, CPU cores, some hard disk storage, and everything. I mean, it's like a desktop or laptop that you know, have with yourself. So these containers are known as the brokers. So these brokers are the servers where you get some amount of RAM, disk, and hard disk, and everything. And combining all the brokers is the Kafka cluster. So Kafka cluster consists of all the brokers individually, and it is designed to scale horizontally. So this horizontally means whenever my data is growing too fast, I need a bigger cluster. In that case, I would introduce another broker. Okay, so if I say have 10 brokers currently, and I see that my data is growing even more, in that case I would need five more brokers. In that case, I have to add five more brokers. Okay, I cannot simply extend the existing 10 brokers. So that is known as the scaling horizontally. And if I talk about scaling vertically, in that case, whatever the existing cluster I have or the existing brokers I have, I simply have to extend them. Extending means, increasing the cluster resources such as the RAM, CPU cores, and hard disk to tackle the issue. So this is another concept about Kafka. Now the fourth one is durable storage. So Kafka persists data on disk for a configurable amount of time, allowing consumers to read data at their own pace. Okay, so as I was talking about the producer and the consumer, right? One publishes, the other one subscribes. So it publish and subscribe to whom? So basically there is in between a conduit or a messenger where the message is being carried by. Okay, where the message is contained or the message is being carried by that particular messenger. Okay, for the moment I'm going to term it messenger, and in the later slide you will understand what this messenger is and how it basically carries the data. So since I am not connected to the producer side, I am getting the data through this messenger. So this messenger has the capability of keeping the data for a configurable amount of time. Meaning I can put it as 7 days, I can put it as 7 months or couple of weeks. It based on how do I want to configure this, so I can keep the data into that messenger, and then I can consume from that messenger whenever I want. So that is the durability of storage. Meaning it's not like since the data is flown, it's somehow the consumer misses that data, or due to some failure in the consumer side, it is unable to consume the messages. It's not that that message or that particular stream of data is like totally lost. Okay, it will be contained into that messenger for some durable amount of time, and then it will be deleted. So that is the capability of durable storage. The other one is the decoupling. So Kafka enables loose coupling between producers and consumers, meaning they don't need to know about each other. Okay, so that's what I just explained. Since there is a third party, or there is this conduit or messenger who's basically carrying this data. So in that case, consumer has nothing to do with the producer, neither producer has nothing to do with the consumer. Okay, suppose I suppose it's like 15th or 16th century. Okay, and there is no email, there is no phone number, but I have to send a very important message to someone. Okay, and think about a setup where I have a pigeon who will carry my message, whatever I write, to that person who is supposed to receive the message. In that case, that pigeon is the messenger. Okay, so once I write the message and put it into the pigeon, in that case it's totally pigeon's responsibility to carry that message. If something happens to the pigeon, in that case I won't be culpable for it, right? So similarly, that messenger has the sole responsibility of containing the message as much as possible. And the last one, but not the least, real-time and batch processing. Kafka supports both real-time data pipeline and batch-style processing via integration with tools like Apache Spark, Flink, or Kafka Streams. So Kafka is obviously carrying the message, right? So on the end side or in the consumer side, there should be someone who would be processing the data. So over there, we can use Apache Spark. So that's where the Spark structure streaming comes in. And there is other tools like Flink, or the Kafka has its own inbuilt streams. That is another API which helps in processing the data. So we can pick any of the three. Usually, Apache Spark is the most popular one in order to ingest the data from Kafka, that messenger, and then process the data. But in some cases, Flink or Kafka Streams itself is used. Right. Another part you might have noticed that it supports both real time and as well as the batch style. So it's not necessarily that I have to flow out data 24/7. Only a continuous streams of data Kafka can carry, and not the batch style. Batch style can also carry, but it's not necessary. Basically, suppose if I have a data sitting at any website or any other server or storage, I can simply use my PySpark API or any other tool to ingest the data from there. So that is the reason that we don't use Kafka for batch style, but it is widely used when it comes to real-time stream. Now, let us look at the architecture of the Kafka, how it looks like. So, it has this cluster setup, right? Just like all the other Hadoop ecosystem tools and the components, it has the same cluster setup, meaning there would be multiple machines or multiple nodes to handle the data, from producer uh, to the consumer. So that's basically it is so that's basically it deals with the fault tolerance as well as the data ever going, storage issue. Okay, so the first one is the producer application that sends data, as explained earlier, to Kafka topics. Okay, now you get to know about this Kafka topic. So topics is the messenger that I have been referring to on and off about. Okay, so those are the messenger or the conduit who carries the message or which contains the message for a certain period of time. Second one, which I just mentioned, topics, a category or field name to which messages are published. Topics are partitions for scalability. Now, since the message or the data could be so high that it needs some form of distributed architecture, and that is the reason where the Kafka comes into play, right? It has the distributed architecture. So the topics would be partitioned accordingly to handle the growing data into different brokers or into different servers, so that it is spread across the whole cluster. If you kind of like sync this session or this architecture with the Hadoop, in that case we have multiple data nodes, right? So whenever the data is getting written into the data nodes, it's not one particular data node where the data is getting written. Okay, it's like different other data nodes where the data is getting replicated and also chunked into some blocks. Each and every block will be into different data nodes. So similar thing happens in topics as well. Now coming to the third point, partitions. Each topic is divided into partitions. Messages in partitions are ordered and identify an offset. Now you may synchronize well with the with the phenomenon of partitions with the Hadoop lake structure, like data lake structure. Over there, it was the same strategy. The data was partitioned into different blocks, and that's how the data stores. Okay, but there is one more thing you need to notice. That is the date in each and every partition, the messages or data are identified by an offset, and similarly, it is ordered by it. So this offset is very crucial whenever there is a streaming data pipeline, because suppose I am ingesting data from my Kafka topic in a continuous manner, that is 24/7. So if something breaks in between and I have to stop the ingestion, right? So the data will stay in the Kafka topic. My consumer has stopped. So when I rerun the consumer need to understand what data it read when it was, I mean, what data it read last when it was up and running. Okay, it has to pick up from where it left off. So it has to resume from the next message. So that is being identified by an offset. Okay, so that is basically the significance of offset. So if I talk about an offset ID, say 001, 002, and so on, and say up to 099, the ingestion was smooth, but after when it comes to 100, something fails, the consumer side stops ingesting. In that case, the data is obviously there in the Kafka topics, right? The data, the full data would be there. But when I start the consumer again, in that case, consumer should be intelligent enough to pick it from where it left off. It shouldn't, pick from 001 only, because those data are already read. In that case, there will be a duplicacy issue. So in order to make it read from 100 only, so that offset will come into play. So it will simply identify the last offset the consumer read, and only after that it will start reading off. So that is the significance of the offset. Third one is the consumers application that read data from topics. Consumers are grouped into consumer group for parallel processing. So each and every consumer might be from different applications, and it is necessary for the data pipeline to have the consumers in a different groups. Meaning, suppose I have a Spark application who is reading the data and putting it into NoSQL. There is another application, say it is running on AWS cloud, and it is putting data into either DynamoDB or Redshift, whatever. Okay, so that topic that I want to read, okay, and the I'm being the consumer, it may be the same topic that the other consumer is reading into AWS Redshift, right? So I have to make sure that my consumers have a group. So only the data, there would be no overlapping, right? The data that is supposed to go to this Redshift is coming into the Cassandra, a NoSQL DB, and the data that is supposed to be on the NoSQL DB is going to the Redshift. Okay, so in order to distinguish each and every consumer, there's a consumer group, and each and every consumer has a consumer group ID. Now, fifth one is the brokers. So Kafka servers that store and serve the data, a cluster typically consists of multiple brokers. Now, this is nothing but the containers, or you may want to call it node. So this is basically the machine where all the resources will be there. Okay, so this broker is just a remote machine setup in the cluster, and it can have multiple brokers. One cluster can have multiple brokers. And last but not the least is the zookeeper. So much like Hadoop data lake, Kafka also works with a master slave strategy. Now, in a Kafka cluster, all the brokers are slave. Okay, there is no like name node or master broker or master node. All the brokers are slave to get the metadata information or to get the instruction from the master daemon. It is the zookeeper who acts as the master architecture. It's a tool used for managing Kafka's metadata and cluster coordination. So it takes care of all the brokers. If any broker goes down, in that case, Zookeeper is always alert on it, and Zookeeper is the first one to notice that if any broker is down, and it will work accordingly to not retrieve data from that particular broker, and only to get the data from different other brokers. So this is the overall highlight of the Kafka architecture, and how each and every components play in tandem to to send the data from the producer to the consumer. If you just look at the picture, so this is a very high level overview of the architecture, where one side there are different producers who are pushing the message into the Kafka cluster, and the other side there are consumers who are pulling the message from the same cluster. Now inside the cluster, you will see three different brokers like broker 1, broker 2, broker 3. And inside each and every broker, there are topic partitions, not topics. Okay, I can see there is only one topic, that is the topic A. So topic A is the only topic over here that is available. Not necessarily that in one cluster there should be only one topic. There could be multiple topics as well. But the fact of the matter is that if you look at each and every broker, the topics, the topic is partition. Like topic A has partition 0, partition 1 in broker 1. In the broker 2, it has partition 0, partition 1, and so on. Okay, so basically each and every broker will have different partitions of the same topic, or maybe of different topics as well. In this picture, there's only one topic being used, so in that case, it is only showing this topic only. So how Kafka achieves the fault tolerance is that suppose one of the broker goes down, so broker 1 goes down. In that case, the broker 2 and the broker n over here, it could be broker 3, 4, whatever. So they are ready to take up the challenge and to exclude this one totally and to retrieve the data or carry the data from these two other brokers only. Okay, so that's how Kafka achieves the fault tolerance. And if you can see that there is the similar fashion of replication has happened, right? This partition 0 is here in broker 2 and partition 0 is here in broker, broker n as well. Similarly, partition 1 is here present in broker 1 and 2. So this is how through the replication and through the distribution, the Kafka achieves fault tolerance and also the high availability, which means the data can be grown like tenfold or manyfold, and still Kafka will be able to withstand that much of amount of data to contain into the Kafka topics. So that's all from this session, folks. If you want to know more about Kafka, if you want to know more about other data lake tools, just reach out to us, reach out to TechSpark. You might be wondering how can I, set up a Kafka cluster in my Windows local, even without the Hadoop data lake. That's possible, and also I can run streaming pipeline. I can ingest the data from Kafka topic. I can create a Kafka topic. I can produce the messages into that same topic, and I can also ingest the data into my PySpark structure streaming code from that topic. So everything is possible. We will guide you. We will show you how to set up all these things into your local machine. Okay, without spending a single penny. So just reach out to us for any queries or clarification. We cover all the necessary tools in our data engineering course, such as Spark, Hadoop, Hive, AWS, a bit of Kafka as well, with hands-on coding and real-world projects. So just reach out to us for any assistance at all. Signing off from the session. Bye bye.
Contact us for the free job assistance. We will help you to get the IT job. Please like, subscribe, and share the channel for more regular updates from TechSpark.